Hi, Jim from AquaTurf International here. In this video, we will discuss water management and the sustainability of golf course irrigation systems. Water shortages are an unfortunate byproduct of the current global environmental crises. These problems used to be regional, but not anymore. In regions where drought has always been a problem, it's now worse. And in others that seldom saw drought, they're now experiencing the worst droughts in 500 years, such as in Europe this summer. Water shortages are no longer somebody else's problem. Water conservation is the #1 issue to ensure a successful future and growth of the game of golf around the world for years to come. We often hear the word sustainability, but what does it mean? According to the UN World Commission on Environment and Development, sustainability is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. According to the R&A, sustainability means optimizing the playing quality of the golf course in harmony with the conservation of its natural environment under economically and socially responsible management. Simply stated, as little brought in and as little taken off of each individual golf course. That is the true simple meaning of sustainability. How can golf course managers use our water resources better? The simple answer has been known for years. Implement the 3 R's of waste management: reduce, reuse, and recycle. Implementation is where the problem lies. We will discuss some examples of how we can better implement these 3 R's in this video. We irrigate when rainfall alone is inadequate so we can present the turf in an acceptable condition to the players or members playing the course. Unfortunately, many regions where golf is popular have less rainfall than needed, so rainfall alone is inadequate. In these regions, rainfall is seasonal and storage inadequate to supply the water required for the entire peak warm weather season, so other sources must be used. Some areas, like Scotland for example, are not as rainfall dependent as others, but for this discussion, we will focus on those courses that do require the most irrigation. Since the U.S. is the largest water user, we will use imperial units rather than metric for this discussion. How much water are we talking about? Obviously, the water requirement can vary greatly by climate, irrigated area, and many other factors. Here are some examples of the amount used by golf courses as a reference. According to the Arizona Department of Water Resources, the public records show 219 golf courses across Arizona used a total of 119,000 acre-feet of water in 2019. The average amount of water used per course was 504 acre-feet during the year, or about 450,000 gallons a day. According to the USGA, the number of irrigated acres per course is approximately 80, with the percentages of each golf area shown in the chart. The 2003 to 2005 study data indicated that 2.08 billion gallons of water went to irrigate golf courses per day. The total water consumption is 408 billion per day. So golf is about 0.5% of the U.S. total water use. The Southwest region is the largest user at approximately 450 gallons per day, or 149 million gallons per year per course. Mountain states are 97 million, Southeast region 79 million, Pacific 51 million, Transition Zone and North Central region are both 25 million, and Northeast region 14 million. This is a range of 150 million gallons per year to 14 million gallons per year per course. With 16,000 golf courses in the U.S., it adds up to a lot of water. At those rates, a little savings can add up to a lot of savings that can be used for other purposes such as family use. In contrast, the water industry estimates that an average person uses approximately 3,000 gallons of water monthly, so a family of 4 uses 12,000 gallons for bathing, cooking, washing, and other uses. At 450,000 gallons per day, a typical golf course in Arizona uses the equivalent of 38 families per day. On a smaller scale, here's some data to help get an idea of the amount of water applied by one golf course sprinkler. Golf course sprinklers are typically spaced at between 60 and 85 feet depending on the climate. Each sprinkler applies between 22 to 45 gallons per minute. So for each 15 minutes of operation, they will apply 330 to 675 gallons of water each. Remember that. We'll come back to it later. In addition to the environment, there are other reasons that also make water use efficiency important. Overwatering has a significantly negative impact on playability. Overwatering negatively affects turf health, promotes weed growth, and flushes the nutrients from the soil. Overwatering causes excessive growth that requires more mowing and other costly cultural practices. Money spent on wasted water is costly. Also, the cost of the power to pump the water is wasted in similar proportions. What are the typical water sources used on golf course irrigation? Specific water sources for 18-hole courses, as indicated by the USGA study participants, are 52% use water from ponds or lakes, 46% use water from on-site wells, 17% from rivers, streams, and creeks, 14% use water from municipal water systems, and 12% use recycled water for irrigation. The water to fill the ponds or lakes, not included in the other sources, could come from rainwater, brackish or salt water, or water from laundry facilities on site or other sources. Multiple sources are utilized for irrigation water, and many facilities have more than one source available. What we use to irrigate golf courses should be limited to no more than's needed and the least desirable source used first, such as recycled effluent water or brackish water. The most common reason cited for golf courses not using recycled water was the lack of an available source, cited by 53% of the respondents to the USGA. Governments need to do their part where possible in populated areas to make this recycled water available for reuse. Also, to as great an extent as possible, irrigation should be from excess rainfall harvested through drainage, stored on the property, and reused for irrigation. For example, Lam Chabang International Golf Club outside of Bangkok, Thailand, harvests rainfall in an out-of-play reservoir that is over 35 feet deep, harvested from the nearby mountains. This water is rationed to supply their irrigation needs throughout the dry season. Some other courses in Thailand utilize such rainfall harvesting as well. Now let's focus on how the water is used and how use can be improved. What factors affect water use and efficiency? The first group are somewhat static fundamental factors that may be difficult or expensive to change, that include climate, golf course design, specifically the total irrigated area, turf type, soil type, water quality, and the irrigation system design. The second group of factors are operational factors that are more easy to change, and they include programming of the irrigation control system, daily operations such as management and adjustment, standards demanded by the clientele, and the desire to improve. We will discuss each of these factors in some detail, starting with the climate. Other than to reduce our own carbon emissions, there's not much we can do to change the heat, humidity, wind, and rainfall, but we can harvest the rainfall we get and store as much as possible for use when it's less available. We can also better respond to the climate by anticipating large rain events like hurricanes and limit irrigation before they arrive. Golf course design can play a huge role in water conservation by limiting the area of irrigated turf. Many modern-day courses are designed by golf architects with a hard-line style, implementing a defined line separating the irrigated turf from the non-irrigated areas of native grasses and plants, native sands, mulch under tree beds, and other zero water use ground covers. Some states, such as Arizona and California, offer programs to incentivize existing golf courses to reduce their amount of irrigated turf. Each acre of removed turf saves nearly 7,000 gallons of water for each quarter of an inch of irrigation applied. A survey of the members of the American Society of Golf Course Architects, ASGCA, revealed that 93% of their member respondents are helping their clients reduce the acreage of their maintained turfgrass while preserving the course's strategic intent. Changes such as these will not only save water, but make the course more strategic and aesthetically pleasing at the same time. If you have an existing golf course, contact one of these ASGCA members to see how you can best accomplish reducing your irrigated turf. It's critical to note that if you do not properly modify your irrigation system at the same time, then the water-saving benefits from the turf reduction will not be properly realized. Contact a professional independent golf irrigation consultant such as ATI to assist with this process. The type of turf can greatly influence the amount of water required. Some grasses are far more drought tolerant than others. Many universities, such as Oklahoma State, perform valuable turf trials to identify turf varieties that are highly drought tolerant while still providing beautiful quality turf. Using brackish water high in salts can also help limit the use of higher quality water sources, leaving better sources for human consumption and agriculture. Seashore paspalum is becoming much more widely used in various parts of the world, due mainly to its ability to grow well with poor quality water, such as gray water, and the fact that it requires roughly half the amount of nitrogen fertilizer as Bermuda. The first ATI project using paspalum was at the Greg Norman designed Emerald Bay Resort in Exuma, Bahamas in 2003. Since then, we've been happy to have been involved with many other paspalum courses around the world. If your course is in a warm climate and have high salt conditions, contact a supplier in your area for more information. Maybe paspalum turf can help you reduce your freshwater requirement or improve your existing turf quality. Soil type is another major factor in water use. Most older existing courses are built on native soils that in many areas may be higher in clay and loam. These soils hold much more water than sandy soils, such as in Florida. This could greatly help reduce the frequency of irrigation required, but the drawback is the tighter clay soils provide more drainage issues to deal with. To improve drainage, many new golf courses are now constructed using a sand cap to help improve drainage, which improves playability. The unfortunate result of the sand cap is that less water is stored in the soil, which causes an increase in the irrigation frequency and water use. As shown in this USDA graphic, each 1% increase in organic matter can result in up to a 20,000 gallon increase in available soil water per acre. Adding soil amendments in the sand capping to retain raw water and release this potential water needs to be better investigated. We must learn to pick our poison: less irrigation or poorer drainage. Proper irrigation system design obviously plays a huge role in the ability to efficiently irrigate, or not. Without a properly designed irrigation system, the golf course superintendent's hands are tied. Some of the main keys in a proper design to provide an efficient system are effective sprinkler spacing. Utilize uniform triangular spacing as much as possible, with the sprinklers placed closer together than far apart. Fully irrigate the total irrigated area. Partially irrigating an area normally wastes water. Poor sprinkler coverage, especially where part circle sprinklers are located along grass perimeters. This will help eliminate water being thrown into non-irrigated areas as much as possible. Implement individual sprinkler control. Finally, quick couplers should be installed so that the entire irrigated golf course can be accessed with a 100-foot of hose, allowing for hand watering of any small dry spots. We're often hired by golf courses to perform evaluations of their irrigation systems because they experience dry spots during a drought. I'll walk onto some fairways with them and feel squish, squish, squish under my feet. They'll often say, well, we also have a drainage problem, even though it hadn't rained in weeks. I quickly explain to them, you don't have a drainage problem, you have an irrigation uniformity problem. I will now explain how that happens. This densogram graphically displays the uneven coverage of 4 sprinklers excessively spaced in an 85-foot rectangular pattern. In the graph, a sprinkler is located in each of the 4 corners. The graphic shows that because of this spacing, the lowest application rate is 0.4 of an inch, while the highest rate is over 0.8 of an inch, more than double the water applied. To eliminate the drier spots in the pattern, the superintendent will need to irrigate to get the low rate areas adequately moist to keep the grass green. In so doing, the high rate areas receive double the rate of water. This causes excessive wetness and poor playing conditions while using double the amount of water needed. Otherwise, the superintendent would only irrigate to get the high rate area adequately moist, leaving several dry spots behind to be hand watered. This rarely happens since it's labor intensive, quick couplers aren't available, and they get fired for dry spots, not wet spots. As a result, huge amounts of water and the power to pump it goes wasted. The 2 graphs show the importance of fully irrigating the total irrigated area. The top graph shows the uniformity of 3 sprinklers overlapping with a part circle on each side and a full circle in the middle of the fairway. The pattern is relatively uniform with a couple small spots of less water applied. Depending on the soil moisture holding capacity of the soil, climate, and the turf type, the slightest differences may or may not require hand watering. Conversely, the bottom graph shows a single sprinkler operating alone. This example shows that half an inch applied in the middle, tapering down to only 0.15 of an inch on the edges of the fairway. In this scenario, if the superintendent tries to get the turf on the edges adequately irrigated, the middle of the fairway will receive 3 times as much water and become a soggy mess. To avoid this, part circle sprinklers with the correct nozzles need to be located along the grass perimeters to fully irrigate the area of turf, not overthrowing onto the turf areas. Then it'll look more like the top graph. Where turf is not needed, it should be removed or converted to non-irrigated, drought-resistant varieties. The control capability of the sprinklers is also of great importance. Individual control of each sprinkler gives the superintendent more ability to manage water. This individual control, coupled with a sprinkler pattern uniformity, offers the superintendent the best opportunity to manage the water to the highest degree possible. Unfortunately, to save money, many golf courses have purchased block systems in which 2 to 4 sprinklers are all operated by one single valve. In this manner, the control is limited since the multiple sprinklers cover a large area that most likely has varying water demands due to slope, shade, soil types, and other variables. Block systems should never be used on golf courses, period. One simple step to potentially save a lot of water is to make sure your irrigation system has an operational rain shutdown feature. Rain often occurs in the evening after staff have left, so no one's there to turn off the system. We've all seen sprinklers running in the rain before, a complete waste of water and power to pump it. A rain shutdown feature can very easily eliminate this problem. The first operational factor is the programming of the irrigation control system. All Gulf irrigation systems should be computer controlled, but just having a computer alone is not adequate. A Gulf irrigation computer is just like all other computers. Garbage in, garbage out, or GIGO for short. With hundreds to over 2,000 sprinklers on a golf course to manage, a computer is necessary to properly communicate to each sprinkler when to operate and for how long. Each sprinkler must be programmed into the computer with the accurate nozzle size, pressure, flow rate, radius of arc, and the precipitation rate data. The computer can then accurately calculate how long to run a sprinkler to replace the daily requirement. The system pipe size and flow capacity of each pipe must also be programmed along with the total flow capacity of the pump. Each time a sprinkler's runtime is changed, the total system flow will also change. The pipe network and pump are limited in their flow capacity, so a properly programmed computer can maximize that capability. This will ensure that the most water can be applied in the shortest time possible, saving money on pump electricity while improving playing conditions. Accomplishing this efficiency without a computer is impossible. The sooner the system can complete irrigation in the evening, the drier the course will be in the morning for play and maintenance. A drier course results in less compassion from golf carts and mowing equipment and is more fun to play. Without question, the most important factor in water savings and playability is the daily monitoring and daily adjustment of the system. I like to refer to this as applying the right amount in the right place at the right time. Basically, no more water applied than is needed, applied only where it's needed and when. The superintendent is the doctor and the turf is the patient. Any good doctor does a thorough evaluation of the patient's vital signs before prescribing any treatment or medicines. A superintendent should do the same. Think before you sprinkle. It really isn't that difficult, but it does take some time, some knowledge gained through training, and desire. How do we determine the right place for the water? Trained personnel should monitor the turf on the entire course continuously during the day for wet and dry spots. The first and simplest method to use is a visual test. It's easy to see when areas are dry. The leaves start to show wilt by turning blue, footprinting, and then turn brown. The sooner to apply the water at this point, the better. Don't wait for the dry area to get larger so a sprinkler can be used. Apply the water to the smallest area first so not to irrigate areas that are not in need, causing other problems elsewhere, wasting water. Many dry spots are no more than a few square feet in size. For example, a dry spot 10 feet by 10 feet is 100 square feet, often much smaller. A small area such as this should be irrigated by hose. Instead of a hose, using a sprinkler with 65-foot nozzle covering 13,000 square feet applies 330 gallons in 15 minutes. A sprinkler with 85-foot nozzle covering 22,000 square feet applies 675 gallons in 15 minutes. Using a hose instead will only use a few gallons to treat only the area in need. Does this require effort? Yes. Is it worth it? Absolutely. If this process alone is extrapolated across the entire golf course every day, it will save millions of gallons of water and provide a far better playing surface. If you had a rash on your arm, would the doctor tell you to put cream all over your body? Of course not. Only the right place. In lieu of supplementing the dry spot, the superintendent could choose to increase the runtime of the sprinklers in that zone during the evening's watering, also wasting water. This happens all the time. Hand watering on greens is quite common, but not so much on fairways or other areas. Why is that? Because greens are of high importance? Greens may have a shallower root system, so they can be more at risk. Hand watering provides the most accurate application of water to the important greens and only where it's needed. And it doesn't apply water on the other areas during the day or into the bunkers, negatively affecting play. Well, it only makes sense that those same key principles be applied to the rest of the golf course as well, saving significant amount of water every day. Areas that are too wet are a little more difficult to visually observe than dry spots unless they're extremely wet. Soil moisture sensors can be a very helpful tool in identifying these wet areas. The moisture sensor can also quantify how wet or how dry the area may be. Soil moisture sensors can therefore be a very helpful tool in determining the right amount to apply. While monitoring the course, any larger areas that are observed to be drier or wetter should also be noted. Those larger areas, not treatable by hose, should then have the station run times adjusted up or down to meet the plant's needs. Using soil moisture sensors in the morning and afternoons to monitor these levels can be very helpful to determine the amount of increase needed on a per sprinkler basis. These adjustments should then be entered into the computer each day. Evapotranspiration, or ET, is the cumulative amount of water transpired through the turf and evaporated from the soil. This is the amount of water measured in inches that needs to be returned to the plant each day to keep it healthy. This could be applied daily or every few days, depending on the climate and the soil holding characteristics of the soil. The deeper and less frequent the irrigation is applied, the better, to help promote deeper rooted, healthy turf. A problem for many superintendents is that they're not familiar with ET as a measurement for how much water to apply. Instead, they think in terms of minutes of irrigation rather than inches. Mother Nature applies rain in inches. Superintendents need to become familiar with ET and the application rate of their sprinkler in inches. The properly programmed computer can then calculate the minutes for each sprinkler to run to apply the correct amount of ET in inches. According to the USGA, most facilities utilize direct observations like these visual inspections of turf grass and soil conditions to aid in irrigation scheduling decisions. Approximately 35% routinely utilize ET data, and only 3% use soil moisture sensors to aid irrigation scheduling. These numbers need to improve significantly. ET data is typically provided from on-site weather stations. These weather stations can monitor the weather factors minute by minute and calculate the daily ET. Otherwise, it's guesswork by whoever's adjusting the irrigation system. No need for guessing. Remember earlier that I mentioned that for each 15 minutes of operation, that typical golf sprinklers apply 330 to 675 gallons of water each? It's easy to see how much water can be saved by reducing the runtime of each sprinkler by just 1 minute, especially considering there can be as many as 2,000 sprinklers or more on some golf courses. Using an example flow rate of 33 gallons per minute and 1,000 sprinklers, that's 33,000 gallons saved per day by just lowering the use by 1 minute a sprinkler. Then 3 minutes per sprinkler is 100,000 saved per day. Small changes can make big results. The standards required by the clientele, whether they're club members or daily fee players, has a significant impact on water savings, believe it or not. Currently, perfection is the standard most clientele seem to prefer. This is understandable human nature. Our expectations are a product of what we see on TV. I call it the Augusta effect. I'm as guilty as anyone. I have a degree in turf management. I love beautifully striped green turf as much as anybody. Unfortunately, it's not sustainable. A superintendent, while he manages the irrigation, has a choice as to whether he keeps the course on the edge of too wet or the edge of too dry. The edge of too wet's the safe bet, while the edge of too dry is riskier. Superintendents get fired for poor-looking turf, not wet turf, based on the expectations of the clientele. This mindset needs to change from the top down, allowing the superintendent the peace of mind to keep the course drier than wetter. We can change the perception from the Augusta effect to fast and firm if we try. Fast and firm can save billions of gallons of water. Yes, billions with a B. There must be desire on everyone's part to make it happen, and we all play a part. A fast and firm course is much more fun to play than wet, green, squish, squish, squish soft turf. Golfers invest hundreds of dollars on the newest driver or golf ball to gain another 10 or 15 yards of distance. If we would just reduce the water and accept a little brown turf, we could all immediately hit the ball 20 yards or farther by getting more roll. We all watch the British Open each year and see the ball bounding down the brownish fairways, see the game played on the ground, hear the players and the announcers talk about how much better and interesting golf links are to play than parkland golf. Then the next week, many of us go back to squish, 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 squish in our standard overwatering. To set an example and to promote water conservation, in 2010, the USGA and Pinehurst No. 2 embarked on a restoration project to return the classical features that it was known for decades gone by and reduce water use. Over 40 acres of Bermuda turf was removed. The fairways were made nearly twice as wide as a typical U.S. Open course, but with essentially no rough. The conventional Bermuda rough was removed and replaced with sandy areas and native vegetation. The irrigated area was reduced from approximately 85 acres to 45 acres. The course went from over 1,100 sprinklers to only 450, with half of them covering the greens and tees. Another area where they conserved water was through the elimination of overseeding in the winter months. They reported that even with a 12% less rainfall in the first year, they used 26% less water than before the renovation. This is a step in the right direction. However, for the reason I explained earlier about uniformity of coverage area, I do not agree with their drastic reduction of sprinklers that do not completely cover the irrigated area. It's well known by irrigation industry professionals that more sprinklers, if properly located, use less water. Can fewer sprinklers work? Yes. But it takes discipline by the superintendent to allow the less irrigated turf edges to turn brown and not over-apply water to get them green. Is it fair to have different parts of a fairway have green and brown turf? I don't know. These are questions that need to be answered by each course. Unfortunately, the USGA and R&A have done little to control advances in golf equipment technology that has greatly influenced the increase in the average length of golf courses by 10 to 20% over the last 20 years or so. For example, in 2000, Augusta National measured 6,985 yards long. 22 years later, Augusta's lengthened to 7,510. The original course at Turnberry was 6,040 yards and is now 7,448. Has this added length made the game more fun? I say no. The game just takes longer, costs more, the ball goes farther offline, and requires more water. Manufacturers can sell as much equipment or more while we control the length. If you don't know how, I'll gladly explain it to you. Many say the added distance is the athletes and not the equipment. Hogwash. I'm 66 years old with a fake knee, and I can hit the ball farther than I did when I was 20. The increase in distance is counterproductive to reducing the irrigated area. Hopefully those in charge will garner the courage to control the manufacturers and get the game under control soon. If not, we're headed to 8,000 yards and more. This can and must be done. Fortunately, baseball used better forethought and forced professionals to use traditional equipment while allowing amateurs to use the newer technology. This allowed the baseball stadiums to remain in their original size as well as protect the records of the great players from generation to generation. Unfortunately, that same model was not followed by those in charge of the rules of golf. Rather than firing superintendents for dry spots, we should be rewarding them for water savings and providing fast and firm conditions. Now there's little incentive for them to keep the course on the edge of dry. Members need to realize that we must manage our water, be accountable for how much we use, and not use any more than needed. This will require investment, which the planning for should start sooner than later. Superintendents need to do a much better job of managing their system. Some systems are well managed, but most could be significantly improved. Conserving water and improving playability at the same time. Better training needs to be provided and a commitment from all superintendents to improve. Golf's the greatest sport in the world, as all of us who love the game know. I believe that the world would be a better place if more people played golf. Golf creates jobs and allows people of all ages and sexes a place to recreate together in nature. We need golf, but we must do it responsibly. That is what all keen golfers would do, because we play by the rules and call penalties on ourselves. Saving water needs to be one of those rules, and we need to start enforcing it. There are many other big gulp users of water than golf, such as silicone chips. Did you know that to produce a single chip can use up to 7,900 gallons of water? Apparel is high on the list of water users, with cotton production and textiles requiring massive volumes of water. Forest products sector is the third largest consumer of water in the U.S., requiring high volumes for pulp and paper manufacturing. The electric power industry uses water extensively for cooling and emission scrubbing. Fossil fuel plants and nuclear plants require hundreds of liters of water for every kilowatt hour of electricity they produce. However, golf is more visible, considered a rich man's game by many and a discretionary luxury, making it an easy target for criticism. As golfers, we know better, but therefore we must do better. Get ahead of the problem and let the public know we have. In some areas, such as the drought-prone West, water usage is regulated and limited. Most of us prefer limited or no government regulation. However, if it's not done voluntarily, as it should be, then governments will soon start doing it for us and create a tax revenue source in the so doing. That's currently happening now on golf courses in China. China knows a thing or two about government control. They've recently levied water taxes on golf courses to reduce water use and increase revenue. This is a photo of a camera focused on a water meter installed by the government on a golf course pump station pulling water from the on-course irrigation lake. The camera is constantly monitored by the local government to make sure they do not unhook the meter. The meter is used to calculate the monthly water tax. They are serious about water use. If industry-wide water conservation is not self-imposed, or until there's a cost associated with water, then excessive water use will probably continue. But if we do not do our part, then governments will have to. With some creative thinking, government assistance rather than regulation, and some changes in perception, we can make a big difference quickly. These could include reducing the irrigated area, improved rainwater harvesting, use of improved salt and drought-tolerant turf grasses, use of soil amendments to improve soil moisture holding capacity, better access to recycled water, better water management by superintendents such as soil moisture sensing and enhanced hand watering, investigate methods to better utilize subsurface drip line where and if feasible, artificial intelligence to help improve daily program adjustments and predict the weather, rules changes to help shorten the courses. Accountability is a good start, and accountability starts with accounting. Every course, as soon as possible, should track their water use closely, develop a long-range water conservation plan and water use goals, fund the plan, and implement it as quickly as financially feasible. prominently display their water conservation plan and goals, monthly water use and savings in the clubhouse and pro shop. Compensate and reward their staff when these goals are met. Let the community know your commitment to water conservation and ask them to do their part too. This can start with you. Ask your golf course or golf club to develop their long-range water conservation plan today. Call an irrigation consultant for help. And remember, a little brown turf is beautiful. Thanks for watching, and please check out some other AquaTurf International videos.